Elastic load balancer concepts. If somebody were to challenge me to teach them AWS in an hour or less, I would focus on three concepts: EC2, VPC, and ELB. Seriously, elastic load balancing is that huge to the overall solution that AWS provides. Cool thing is, the concept is simple. Elastic load balancing allows you to assign a public, we'll put an elastic IP address, right? Or private even, you can use them internally, IP address to a device. This is the, I'll just put a cloud around it, right? The mysterious device in the AWS cloud. What is it? You can't know. But when you assign an IP address to it, you can then dictate what instances that points to. So let's just say I put an HTTP listener on that thing, so TCP port 80. I can then say, okay, and I want, when requests hit this guy, it to go to one of these three instances that I have sitting behind that elastic load balancer. On the simple scale, it can do load balancing. I can say, okay, send one here or one there. Or you can get more complex algorithms. You can say, well, I want 30% of the traffic to go to that one, 20% to that one. This one's kind of a big one, so let's that instance gets 50%. I mean, there's different algorithms that you can use, but that's what the concept of elastic load balancing does. Now, why this is cool is, number one, it works across availability zones. So these instances could be existing in altogether different data centers, which is awesome, because you could then have a let's just say a web page that's being hosted on there. Here's the internet, right? A hurricane comes in and wipes out this data center, which actually has happened. Wipes out this AWS data center. The elastic load balancer detects the failure and automatically reroutes the traffic to these other two. Now, that's another feature of the elastic load balancer. You can set this thing to do health checking on the load balancing server. So it's not just a load balancer where it's like, ooh, wow, I can distribute my traffic between multiple devices, which, oh, I was going to say more, but let me finish my thought, which is good. But you can also use this as a huge level of redundancy, where you can say, hey, you know what? Why don't you do a health check? I'll just put HC right here on this guy using TCP port 80. And you could even go further than that. I mean, maybe this guy gets hacked, right? He gets owned by somebody out in Taiwan and, totally hoses up the web page and everything like that. You can actually have the health check come in and say, you know what? I'm looking for index.asp. And I'm expecting that when I go there, the response is going to look exactly like this. I'm going to see these lines. And if it doesn't return that response, bam, load balancer removes that guy from the picture and now uses the other two as failover. But meanwhile, the elastic load balancer continues to do the health checks against the instance, so that when the instance is restored and comes back online, it can say, all right, you're good. I'm adding you back into the load balance cluster, which is pretty awesome. And actually leads me to point number 3 here on my list. Integrates with auto scaling. Oh, what an amazing feature. Can I just tell you the power-packed punch that ELB and auto scaling put together? So what is auto scaling? Auto scaling is where you can combine two features. I wouldn't even say features, two concepts. One of them is considered the golden AMI. Essentially, an AMI being your hard drive image. You can create this almost perfect hard drive image that represents these instances. Maybe these are web servers, right? I can say I'm going to create the perfect hard drive of a web server. But no hard drive is ever perfect, right? Because as time goes on, that thing gets out of date. So that's where you combine it with bootstrapping, meaning as that almost perfect hard drive begin to boot, it does, we'll say Ubuntu updates or Windows updates. It gets some new files copied over from S3 to populate that web server with the most modern PHP scripts or image libraries or whatever the case is. That's what bootstrapping is all about. So auto scaling means that you can set parameters. You can say, you know what, if this elastic load balance group of server ever goes below 3 servers, meaning it's doing a health check, you can actually configure this thing that it's doing a health check. It's like, you know what, you're not healthy, die server. Matter of fact, Amazon encourages you to do that. They're like, you know what, your server's not doing well, terminate it, kill it, do not try to fix it. That's the new mindset of Amazon Web Services that it brings to the world. It's like, servers are not valuable, they are workhorses, and if they aren't working, kill them, shoot them right there. This is getting pretty violent. So anyway, you kill it, you shoot it, and then auto scaling kicks into play, spins up a brand new instance on a new server. Maybe that server was getting bogged down, maybe it was having some bad hardware, who knows? Auto scaling can spin up a new instances and fill in the load. Not to mention, it can integrate right with the API of elastic load balance. So part of your bootstrap script can say, you know what, talk to the elastic load balancer and let them know that you're here. and let them know that you want to be part of the cluster, right? Because maybe it's not just, an instance going bad. Maybe you run a website like woot.com, where they have these giant sales or something like that, all of a sudden brings 1 million people running to your website all at the same time. Well, you can have auto-scaling be like, whoa, CPU, memory, request amount going higher, scale, start spinning up using auto-scaling all these new instances across mini data centers, and use the API of the Elastic Load Balancer to add yourself in, and now we can handle the load. Nobody even knows we added 100 servers behind the scene to handle this brand new Woot LCD TV that was just announced to the world, right? You see what I'm saying? So, I know this is all about elastic load balancing, but this just makes me want to stop and talk about how cool the new cloud world concept is for what you can do. So, and then. No, you're like, be done. No, and then with auto scaling, once you drop below a certain load level, you can be like, okay, terminate. So your cost that you're paying to AWS goes down. That, my friends, is awesome. Okay, so we've got auto scale. Oh, this is it's kind of a note. Used internally and externally, meaning I can have this facing the internet. Maybe these are all web servers, right? I can also use them internally. So here's my ELB number 2, because all those web servers have to go to a database server, right? So maybe you have a whole bunch of database server instances, and that ELB is going between them. Totally works inside, outside, upside down. One thing, and I'll call this bonus info. One thing that you will find a much debated topic is, what about this guy? Meaning, let me finish my thought. Meaning, I have a single elastic load balancer, right? 3 instances, single elastic. You see where I'm going with this, right? The question then becomes, okay, what if that guy goes down? Then it doesn't matter. Now, this is where you're going to get in. I try this. Go Google, is the elastic load balancer redundant? And you will get no answer. You'll have some AWS guy being like, yeah, this is a redundant design, and then people are like, oh, great, somebody responded. How is it redundant? AWS says. They don't reply. I'm like, come on. They will not tell what the architecture is behind that elastic load balancer. So what you start seeing people do, paranoid people, I'll throw myself in that paranoid camp. They'll spin up a second load balancer, and they'll say, you know what? I'm going to use Route 53, the Amazon DNS, as a kind of another layer of redundancy, because you can point multiple load balancers at your instances. You pay for it, but that's okay. This says Amazon Web Services. Maybe that's why they're not telling anybody. So you can then use Route 53 to be like, hey, like CBT Nuggets totally runs off of Amazon Web Services, right? You can say, when somebody goes to cbtnuggets.com, 50% of the time give them this load balancer, 50% of the time give them this load balancer as their IP address reply, right? And meanwhile, do health checks on both of these guys so that if either one of those load balancers go down, we can route all traffic to the other one, right? So you can add redundancy to your redundancy if you want to, but if you Google enough, you will find some Amazon documentation somewhere just saying, yeah, we designed the load balancer well. It's highly available. How? We're not going to tell you. So Elastic Load Balancer, last couple features, supports cookie-based sticky sessions. So that means that when a web browser, I'll put web browser right here, comes in, you can say, you know what? I always want you to go to that instance for you, my friend, for you. Now, I would say that's probably not a good design, because Amazon says you should be, well, and this is a big picture, should be offloading a lot of your session state to a dynamic database like, I'll just put DB, DynamoDB, like a NoSQL, just throw it in there kind of database, so that even if this instance goes down, there's no session state on there. Like this guy's web browser never even knows he flips over here because all that's stored in another database. But if you want to, you can. You can put sticky sessions on this Elastic Load Balancer so that person always goes to the same instance. Finally, a lot to say about ELB, right? It does support SSL offloading. So one of the things that can crank up the CPU on your instances is it having to do SSL encryption and decryption all the time for all the different secure sessions that you have coming in here. Well, what you can do is offload that to the Elastic Load Balancer, so all the SSL terminates right here. There's a price to pay, but that's okay, because it makes your instances perform better, so you can have less of them, so it caches in. So SSL stops there, and then you just do HTTP, which is a much easier protocol to handle down to the instances themselves. You now know what an Elastic Load Balancer is all about and why you would want to use one. I hope this has been informative for you, and I'd like to thank you for viewing.